In this video, I want to make some data that follows a quadratic polynomial so that I can perform polynomial regression with respect to this data. So I'm going to use make regression from scikit-learn. So from sklearn.datasets, import make regression. And what this does is it's not going to make a quadratic formula for me directly. Instead, it's going to make linear data for me. So let's do this. And I practice to find some numbers that work well in this case. So I'm going to say make regression, and then number of samples, I'm going to take 1,000. Number of features. So this is like how many input variables do I want to have? And I'm just going to have one input variable. So my eventual polynomial function, it's going to be f of x, not something like f of x1, x2, x3. So just one input variable. I'm going to say bias equals 15. Okay, so that's like adding 15 to whatever the line equation is. So it's like the y-intercept, this bias equals 15. I'm going to say noise equals 20. So that's saying that the amount of randomness for this data should follow a normal distribution with standard deviation 20. And I tried this a couple times and got very different results. So I'm going to specify a random state so I know what to expect. And I'm going to say random state 4. That was just one that worked well for me. You could replace this with any integer you want. Okay, let's try this. So good. And what this is doing is it's returning a tuple. It's returning a tuple of length 2. So let me do tuple unpacking here. X comma y. And let me put x and y into a data frame. So I'm going to say pd.dataframe. And then I'll use a dictionary here. I'm going to say the x column is going to come from this x, and the y column is going to come from y. So you should imagine x is going to be fairly regular looking, and then y is going to be some coefficient m times x plus this bias 15, okay, plus some random noise. And if I had made this number bigger, it would be like more extreme randomness. And let's see what happens when I try to do this. So it gives me this error that the data must be one-dimensional. And so what does that mean? Well, let me look at the shape of this x that was returned. So if we look at it, it kind of looks one-dimensional. Okay, like there's just one axis for this, but like let's just look at the first 10 of them. Okay, but we should think of this as two-dimensional. We should think of this as like a little matrix with just one column in it. So it's like a column vector. And so I'm going to reshape this. I'm going to say x.reshape. And x is a numpy array. If I check what's the type of x, it's a numpy array. And numpy arrays have a reshape method. And if you say reshape -1, then it just like flattens it out into a one-dimensional thing. So if I do dot shape, okay, now it's just length 1,000 and there isn't a second dimension. Okay, so do you see the subtle difference between 1001, which has 2 dimensions? Okay, the rows axis here with the 1000 and the columns axis here with the 1, versus here there's just one axis. Okay, and it's length 1,000 along that axis. Okay, so let me take this code for the data frame, and I'm going to save it with the name df. And so the whole point of what we were just doing was I need to reshape the data. Okay, and now it works without that error. Good. And let's try plotting it. So altair.chart df. I'll do a scatter plot, so mark circle. And then I'm going to encode the x-axis using the x column of the data frame and the y-axis using the y column of the data frame. So there you can see it's not a perfect line, but it's pretty close. Okay, great. And so really what I want to do is I want to get rid of that y column because I don't want to have a line. I want to have a quadratic polynomial. So all I'm going to do is I'm going to square it. So I'm going to say replace the y column with the square of the y column. And make sure you only run this code once. Okay, otherwise you'll get like the fourth power of the original y column. And then let me copy this. And the random state, that was finding something where when I square this, it still looks like a nice quadratic equation. It's going to look like a parabola, whereas sometimes for some other choices of random state, it just looked totally random. So let's look at it. Okay, perfect. So only thing I might like to change is I think I would like some of these values to be a little bit smaller, so it's not going up to like value 16,000. So let me say dfy, okay, let me do it a different way this time, times equals 1 over 50. So that's going to say multiply the y column by 1 over 50 and replace the old y column with that. So that's just going to rescale things down, like squash it by a factor of 50. So the shape should look basically exactly the same. It's just now instead of going up to 16,000, hey, like the y-axis did before, now it's just going up to presumably about 16,000 divided by 50. And that should be what we're getting here. Like, let's check 16,000 divided by 50. Okay, 320. So I guess that's where this maximum point, maximum y value point is showing up.